Let's solve this derivative problem step by step. We're asked to find the derivative of 7x cubed minus 2x. To solve this, we'll use the power rule of derivatives. The power rule states that when we take the derivative of x to the n power, we multiply by the power n and then reduce the exponent by 1. Let's write this in derivative notation first. We're taking the derivative with respect to x of the entire expression. Now, let's handle each term separately. For the first term, 7x cubed, we'll multiply by the power, which is 3, and reduce the exponent by 1. So 7 times 3 is 21, and x cubed becomes x squared. For the second term, negative 2x, remember that x is the same as x to the first power, so we multiply by 1 and reduce the power by 1. This gives us negative 2 times x to the 0 power. And remember, anything to the 0 power equals 1. So this simplifies to just negative 2. Now we can combine our terms. 21x squared minus 2 is our final answer. Let's verify this is correct by looking at our original problem. Let's summarize what we did. First, we used the power rule on each term separately. Then we multiplied by the power and reduced each exponent by 1. Finally, we combined like terms to get our answer. As a bonus, we can visualize what this means graphically. Here's the original function in blue and its derivative in green. Notice how the derivative shows the slope of the original function at each point. Let's solve this calculus problem step by step. We need to find the derivative of 5 over x plus natural log of x. First, let's write this as a derivative expression. We'll take the derivative with respect to x of the entire expression. Now, we can use the sum rule of derivatives, which tells us that the derivative of a sum equals the sum of the derivatives. So we can separate this into two terms. Let's handle the first term. For 5 over x, we can rewrite this as 5 times 1 over x. Using the power rule, the derivative of x to the negative 1 is negative 1 times x to the negative 2. So 5 times negative 1 over x squared gives us negative 5 over x squared. For the second term, we know that the derivative of natural log of x is 1 over x. Now we can combine our results. The derivative equals negative 5 over x squared plus 1 over x. Let's review the key steps we used. First, we used the sum rule to separate the terms. Then we used the power rule for the first term and the natural log derivative rule for the second term. Finally, we combined our results to get our answer. Let's solve this differentiation problem step by step. We need to find the derivative of the square root of x to the 5th power. The first step is to rewrite this expression using fractional exponents. Remember, a square root is the same as raising something to the 1/2 power. So the square root of x to the 5th power can be written as x raised to 5/2. Now that we have our expression in terms of a power of x, we can use the power rule for differentiation. The power rule states that when we differentiate x to the n power, we multiply by the power and reduce the exponent by 1. Let's apply this rule to our problem. Our n is 5/2, so we multiply by 5/2 and subtract 1 from the exponent. The final step is to simplify the exponent. 5/2 minus 1 is the same as 5/2 minus 2/2, which equals 3/2. Therefore, the derivative of the square root of x to the 5th power is 5/2 times x to the 3/2 power. Let's review the key steps. First, we converted the square root to a fractional exponent. Then, we applied the power rule for differentiation. Finally, we simplified the resulting exponent to get our answer. Let's solve this derivative step by step. We'll start with the expression 1 over the square root of x to the negative third power. Let's first understand what we're trying to do. We want to find the derivative with respect to x of this expression. The first step is to simplify what's under the square root. Remember that the square root of x to a power is the same as x to that power divided by 2. So the square root of x to the negative third is equal to x to the negative 3/2. Next, we can simplify this fraction. Remember that when we have 1 over x to a power, that's the same as x to the negative of that power. So 1 over x to the negative 3/2 becomes x to the positive 3/2. Now we can use the power rule to find the derivative. The power rule states that the derivative of x to a power n is n times x to the power n minus 1. Let's apply this rule to our expression. In our case, n is 3/2, so we multiply by 3/2 and subtract 1 from the exponent. Finally, let's simplify the exponent. 3/2 minus 1 is equal to 1/2. Therefore, our final answer is 3/2 times x to the 1/2 power. Let's review the key steps. First, we simplified the square root expression. Then we converted the negative exponent to a positive one by moving it to the numerator. Finally, we applied the power rule and simplified the exponent. Each step helped us transform a complex expression into a simpler one while maintaining the same mathematical meaning. Let's find the derivative of the cube root of x plus 1 over the cube root of x. We'll solve this step by step using the power rule and chain rule. First, let's rewrite our expression using fractional exponents. The cube root of x can be written as x to the 1/3 power, and 1 over cube root of x can be written as x to the negative 1/3 power. Now, we can use the sum rule of derivatives. This means we can differentiate each term separately and add the results. Let's use the power rule to differentiate each term. Remember, the power rule states that the derivative of x to the n power equals n times x to the n minus 1 power. For the first term, we have x to the 1/3 power. Using the power rule, we multiply by 1/3 and subtract 1 from the exponent. This gives us 1/3 times x to the negative 2/3 power. For the second term, we have x to the negative 1/3 power. Using the power rule, we multiply by negative 1/3 and subtract 1 from the exponent. This gives us negative 1/3 times x to the negative 4/3 power. Now let's combine these terms. We have 1/3 x to the negative 2/3 minus 1/3 x to the negative 4/3. Finally, we can factor out 1/3. Our final answer is 1/3 times the quantity x to the negative 2/3 minus x to the negative 4/3. Let's review the key steps we used. First, we rewrote the expression using fractional exponents. Then we used the sum rule to separate the terms. Finally, we applied the power rule to each term and simplified our result. Let's solve this differentiation problem step by step. We start with the expression x cubed minus x to the 7th, all over the square root of x. The first step is to rewrite this expression to make it easier to work with. We can rewrite the square root of x as x to the 1/2 power in the denominator. This gives us x cubed over x to the 1/2 minus x to the 7th over x to the 1/2. Next, we can simplify each fraction using the laws of exponents. When dividing terms with the same base, we subtract the exponents. So x cubed over x to the 1/2 becomes x to the power of 3 minus 1/2, And x to the 7th over x to the 1/2 becomes x to the power of 7 minus 1/2. Let's simplify these exponents further. 3 minus 1/2 equals 5/2, and 7 minus 1/2 equals 13/2. So our expression becomes the derivative of x to the 5/2 minus x to the 13/2. Now we can use the power rule to differentiate each term. Remember, when differentiating x to the n power, we multiply by n and reduce the exponent by 1. For the first term, we multiply by 5/2 and subtract 1 from the exponent. For the second term, we multiply by 13/2 and subtract 1 from the exponent. Let's simplify these exponents. 5/2 minus 1 equals 3/2, and 13/2 minus 1 equals 11/2. This gives us 5/2 x to the 3/2 minus 13/2 x to the 11/2. Finally, we can factor out 1/2 to write our answer in its simplest form. 1/2 times the quantity 5x to the 3/2 minus 13x to the 11/2. And that's our final answer. Let's review what we did. We rewrote the square root, simplified using exponent laws, applied the power rule, and simplified our result to get this final expression. Let's solve this differentiation problem step by step. We start with the expression, the quantity x minus 1 squared divided by the cube root of x. First, let's simplify our expression. We can rewrite the cube root of x as x to the power of 1/3 in the denominator. Then we'll expand the numerator x minus 1 squared. Next, let's split this fraction into 3 terms. We'll have x squared over x to the 1/3 minus 2x over x to the 1/3 plus 1 over x to the 1/3. Now, we can simplify each term using the laws of exponents. Remember, when dividing powers with the same base, we subtract the exponents. This gives us x to the 5/3 minus 2x to the 2/3 plus x to the negative 1/3. Now we can differentiate each term using the power rule. Remember, the power rule states that the derivative of x to the n equals n times x to the n minus 1. For the first term, we multiply by 5/3 and reduce the power by 1. For the second term, we multiply by 2/3 and reduce the power by 1. And for the third term, we multiply by negative 1/3 and reduce the power by 1. Let's simplify the powers in each term. This gives us 5/3 x to the 2/3 minus 4/3 x to the negative 1/3 minus 1/3 x to the negative 4/3. And there we have it. We've found the derivative of our original expression. Let's review what we did. We first simplified the expression and split it into terms, then used the power rule to differentiate each term, and finally combined our terms into a single expression.